ANSYS Simulation Lecture 4 Composite Materials. Open the part file. And enter sketch mode. Draw a rectangle 100 by 100. And make it into a planar surface. Save the file on desktop. Now enter ANSYS Workbench. In composite materials, the material part is the most important. So I have already opened the material property data. This is the data sheet for T300. So I'll implement static structure analysis. And for material, I'll enter material procedure. And I'll duplicate this material and define it as 300. Now it is an isotopic material, so instead I'll drag and drop here, and now the isotopic materials is crossed out, and we have orthotopic material. So I'll copy the material properties from here to here. Young's modulus, Poisson's ratio, and shear modulus. So this is what we need for the properties for T300. So this is a carbon epoxy composite. So I'll go back to project, and this is the organized interface. And I have already defined the T300 material. So I enter ANSYS mechanical interface. And in this mechanical procedure, I will make sure that the material property is connected to the geometry. And because the geometry is a planar surface, so we need to enter a thickness. But the thickness here, you can simply enter 1. It is a dummy thickness. The real thickness will be defined in layered section. Layered section means it is a composite laminate, and we will define the geometry in this layer, in this area, and the coordinate system will be the body coordinate system. And for the layers, we enter worksheet, and we'll add layers here. Add 4 layers on the top. You can also add 4 layers at the bottom. So we will make it totally 8 layers. And for the material, we'll change into T300. Okay, and the thing is 0.1 millimeter. And for layer 2, the direction is 45 degrees. Minus 45. For layer 4, 90 degrees. So this is also a symmetric composite panel. So this is the important thing. It is also important that you define the material to T300, and you define a layer section here in the geometry by right click on the mouse and choose layer section. And in layer section you enter a face like this. You select a face and use body coordinate system and work with the worksheet here and edit all the worksheet. So these are the most important procedures for composite material simulation, and all others are the same, but you can manipulate with the size of the elements. For example, you can make the element size smaller. For example, we can make it 10 millimeters and remesh. So I get it. I'll make it even smaller. 2. Update. So I get a finer mesh. 2 millimeter. Generate mesh. Okay, this is the mesh that I need. So I'll go ahead and fix support this side. I'll fix support this side, for example, and then I'll apply a load, a concentrated load on this line, and this is the force application area, and the direction is normal to this area. So for the direction I'll choose this one, apply. So this is the geometry that we choose, this line, and for direction I choose this area. Okay, for magnitude I'll enter 100. So I exert a 100 Newton force on this line along this direction. So for solution, I need total deformation and volumetric stress, and run the procedure, run the study, and I'll get the deformation. You can see from here that it is a 3D model. It had thickness of 0.8 millimeters. So it is also shown in 3D display. So even if the model is 2D, the CAE structure, CAE result is 2D, is 3D display. So for total deformation or for stress, you can choose different layers for display. So you can always choose the layer. For example, layer 4. This is the stress for layer 4. So this is a neutral surface, like this, layer 4. Upper surface is on neutral plane, and the lower surface is connected to layer 3. So it is correct.